Okay, hi guys. So today we're going to be looking at linear inequalities. So that's your chapter 2 for your syllabus. So let's look at the learning objectives for today. So you should be able to solve linear inequalities with one variable and represent it in a number line. I believe you should have learned this before already. And then on top of that, you should apply linear inequalities to solve word problems. And um, lastly, you should be able to solve simultaneous equation using linear inequalities. Okay, so now let's get going. Okay, so firstly, you should know how to draw linear inequalities in a number line. So let's take a look now. So let's say you have a equation that is, for example, x is greater than equals to 3. So when you draw a number line, 0, 1, 2, 3, 4. Let's say you have drawn a number line. So if it's more than or equals to, it will be a solid circle, and then you write x more than equals to 3. If, for example, it is x is less than 2, then again is similar. 2, 1, 0. And then in this case, it's not a solid circle. Okay? X is less than 2. So this is your basics of drawing a number line. Now, let's see. The next part is multiplying and dividing by a positive number. So, if you multiply and divide by a positive number, so for example, if you have x is greater than equals to y, then given that c is greater than 0, when you multiply by c, when you multiply by c, your inequality sign remains the same. So it still stays as xc is greater than equals to yc. Your inequality sign doesn't change. However, if you multiply it by a negative number, so let's say initially you had x is greater than equals to y, then now given that c is less than 0, okay? So that's the only difference. So when you multiply, you'll get xc is lesser than or equals to y yc, okay? So that's the only difference. So let me write it in another color. Your inequality sign changes. Sign remains the same. Remains the same. Oh yeah, by the way, this triangle means change, okay? Just for your information. Okay, so that's just a quick recap of what I've learned so far. Now let's do some example question. So sometimes your equation you got to manipulate it first. So let's say if I gave you this question and ask you to draw on a number line, you bring the 4 over, so it becomes x is less than minus 1. So again, same thing, minus 1, minus 2, 0. It's not a solid circle. You draw the number line. Okay? And then if you have a this kind of equation, again, you gotta make y the subject of the equation, okay? It's very similar to your simultaneous equation, it's just solving for y. Just that in this case it's an inequality. So you bring your constant to your other side. So you get 16. Y is minus y is more than equals to 4. You remember when you divide by negative, your sign changes. So therefore y is lesser than equals to 4. Okay? So in this case, it's a solid circle, and then yeah. Okay. So that's about it. Now let's look at another question. So I want you to pause the video first, and then uh and try out this question. So I'll be doing the working in a bit. Okay, so again, it's the same question. I hope you have managed to get the answer. So they give you an inequality and they want you to illustrate in a number line. Okay. So I'm not gonna do the number line part, but I want you to do it yourself. So 8 minus x more than 3. So if you bring the x over, you get x, and then you bring the 3 over, less than 5. Okay? Alternatively, you can bring the constant over, you get minus x is more than minus 5. Then you multiply by negative. So when you multiply by negative, remember the sign changes. Okay? You get the same answer. Then you got to draw this on a number line. So I believe you should be able to do that part by now. Then if x is a prime number, write down the largest possible value of x that satisfies the equation. So in this case, it's not less than or equals to, so the largest possible value is of x is equals to 3. Okay? Remember, it's a prime number, it can only be divisible by 1 and the number itself. Okay? Okay, part 2. Write down the positive integer values of x that satisfies the inequality. So positive integer value. So it's just 1, 2, 3, and 4. Okay. 5 is not included because it's not less than or equals to. So this is a typical linear inequality question. Right. So now, okay. So I want you to pause pause the video here. So please try question 2 and question 6 in your free time. So if you have any questions that you're not sure of, uh do text me a message and I'll help you out, okay? So other than these two questions, you are free to try the other questions as well. Then let me know if you have any questions, okay? Now let's move on. Okay, so now we'll be looking at the second learning objective, which is applying it to your word problems. Okay, so again, it's almost the same thing. It's a very similar concept. So let's take a look at this question. So there are 20 MCQ questions in a test. 3 points are awarded for a correct answer. 1 point is deducted for a wrong answer, and no points are awarded or deducted for unanswered question. So it is given that he attempted a total of 19 questions and his total score was above 32. Okay? So your first step is you need to have okay, so this is a very common question to begin with. So how it goes is you need to use algebra. So the method to go about this is, let's say, let the number of correct answer be x. Okay. So once you have that ready, the number of wrong answer is equals to 19 minus x. Because it's given that he answered 19 questions. So now we can calculate the scores in terms of x. Okay. So 19 minus x times minus 1 plus x times 3 is more than 32. Okay, so you have this inequality already. So once you get to this step, the next step is just to simplify it and then you get the answer. So you get x minus 19 plus 3x more than 32. 4x is more than, wait, let me get my calculator. 32 plus 19 should give 49. Sorry, 51. Okay, goes to 51. X is greater than 51 divided by 4, which is 12.75. So, the question says find the minimum number of correct answer he obtained. So in this case, your number of questions cannot be a decimal place, so you got to round it off to the nearest whole number. So since they asked for a minimum number, your answer should be x is equals to 13. Okay? Yeah, it can be 14, 15, or even 19. So 19 is the maximum it can be. But they asked for minimum, so it is 13. Okay? So this is a typical question. We will do more questions during lesson. Okay, now we will look at the last part of the lecture. So this is actually a very short topic. So yeah, let's take a look at this. So it's the same thing as we have learned before, just that now you have two different equations, and then you need to find a range of values given the two different equations. Okay. So let's see. So you have your first equation where 3x is less than equals to x plus 6. So when you simplify this, you'll get 2x is less than equals to 6, x is less than equals to 3. And then on your right hand side, you have your second equation, which is 2x plus 4 is less than 3x plus 6. So again, when you simplify this, you'll get minus x is less than 2, x is greater than minus 2. Okay. So once you have this number line, your next step is just to, sorry, once you have these two equations, the next step is just to draw the number line. Okay, this is if the question asks for a number line. If not, you can just straight away write the answer. So you start off with minus 2, minus 1, 0, 1, 2, 3. So x is less than equals to 3. Okay, sorry, let me draw it properly. So you have the two different equations here. So when you combine them, your shaded area is just your common values are just all this area. So it will be x is more than minus 2 or less than equals to 3. So this is your final answer. Okay? So this is how you do simultaneous equation. So now let's look at a very similar question. So at this point again, I want you to pause the video and try it out yourself. I will reveal the answer in a bit. Okay? So let's take a look. So given that x is between 7 and 0, y is between... Find the greatest possible value of x plus y. So greatest possible value would be 7 plus 5 equals to 12. Then least possible value of x minus y. So least possible value, got to take the smallest value of x minus the biggest value of y equals to minus 5. The largest possible value of xy. So again, take the largest numbers, you get 35. Smallest possible value of x over y. So in this case, for smallest possible value, uh if you have a negative number for y, you should choose the biggest possible value of x. So for example, let's say if this goes until negative 1, right? Then you got to choose 7 over negative 1 because this gives the smallest value. But in this case, you don't have a negative value, so you choose the smallest possible value of x over smallest possible value of y, so this gives 0. The least and the greatest possible value of x square. So the greatest possible value would be 7 square equals to 49. The least would be 0 square, which is equals to 0. Okay. So for this kind of question, It's in this case it's very simple, but it will be more challenging if you have negative numbers involved. So okay, how about you try this question? So the same question, just that your x is between uh 5 and -3, and your y is between um let's say your y is in between 6 -6 and 1. Okay, so I want you to try out this question, and the these four parts are the same, and then we'll go through during lesson. Okay. All right, so that marks the end of this chapter. It's a very simple chapter. If you have any questions, again, just do drop me a text. Okay, thank you for watching. Bye bye.